appreciate if you have any novel solution to this problem, but probably, yeah, repeat the questions maybe. Okay, so let's begin. So first of all, I want to thank you all for your activities in Piazza. So there are several things that came in the last days. So first of all, regarding the homework, I didn't expect such a big contribution. Thank you all. That was great. And then there were, so there are other people, for example, with the tips and tricks. I hope you can see it. So Artemi, do we have you here or? Okay, so anyway, thank you as well for sharing some tips and tricks. You can also do that if you think anything could be helpful for the other students, please share it there. And there was also one important note was here about the recorded videos. So if you want to open the videos on the Dropbox website, you can see it until only the first 60 minutes. And otherwise, you need to download the video, or you have a professional account in Dropbox. So that's the only way you can see the whole videos. I have the plan to upload everything to YouTube. I don't know if it will make sense. Then we don't have any issue anymore. But yeah, so I will let you know if we decided to move on to YouTube. Then yeah, I will inform you on the Piazza. And finally, regarding the where do we have it here? The book and resources. So I hope every one of you could find the resources on OLED. Am I right? So if there was any problem, just write it here. So I just uploaded the second chapter of this book. So I got some screenshots of this book and uploaded in the OLED. So today's lecture would be mainly on this. And now I'm a bit more confident about this book because I just realized it yesterday that there are 3 people who endorsed this book, and 2 of them just got the Nobel Prize this year. So that's a great thing. You can just have the book if you want to look at this. Yeah. So yeah, but I will upload the relevant chapters on OLED, those chapters that they include in the class. Okay. So good. Now, okay, let's start with our agenda today. So today we talk about data wrangling, and didn't find a very good definition for data wrangling, but these pictures shows you what the idea behind it. So this is a very boring process of cleaning a data set. And basically, you can see it's like kind of a punishment for those who want to do machine learning. They need to spend around 80% of their time cleaning their data. Otherwise, it will be a garbage in, garbage out for sure. So this is a very boring process, but you need to do it enough that you can be a master of this. And in this course, we will mainly focus on the abilities that you will learn to do this data wrangling, and most importantly, the data cleanings. So what do we do here? So we have, I will introduce you first the types of variables and observations we have, and then how we can organize them in a tidy way. And then we will start with the cleaning of the data and the procedures that you need to have, like a workflow to clean and organize the data. And then I will have a talk about the documentation of this process. And in the second part of the class today, we will cover Pandas, which is the most favorite library for the data scientists, I guess. And yeah, great. So, any question about what we're doing today? Okay. But there was like a question, I guess, in the Zoom. Okay, no. So we have, okay. Okay, let's the homework solution done. No, I prefer not to have the solutions. I think you are already very good in the Piazza, so I think that it's already good enough. So you don't need my solutions. Yeah, regarding the homeworks, so those homeworks that we will do after the classes, they are not graded, but your discussions in the Piazza forum is graded. So like just your contribution matters at the end. So I don't gather like how good or bad you did your exercises. Those exercises are needed for you to be good in doing this stuff. And yeah, especially if you don't have a good programming knowledge, that's the best way to practice the things that we teach into the classes every session.
I understand that you are reluctant to post your own solution.
Yeah, you can, I think this way you can talk.
I think I understand that you are reluctant to post your own solution to Piazza, but maybe we invite the stronger students or the students that have interesting solutions to post the solutions, but be able to put them in one approach. With something that seems to be well and running.
Yeah, but in Piazza, I always mark those questions, those answers that I think they are good enough. So if they're like this green note that the instructor like endorsed this solution or something, it means that, yeah, I like that. So basically, I think at the end, there's no right and wrong thing here. And that's why I don't want to like stress the students with like this solution and so on. So. Okay. Yeah, and finally, it's related to the potential bonus for grading. Okay, so this is already answered. Great. Okay, so the types of variables. So we have two types of variables mainly. First part is quantitative variables, that they are born as numbers. So it could be like integer, floats, whatever kind of number. And they are mainly categorized in two subgroups of flow variables and stock variables. By flow variables, I mean those kind of variables that have a certain element of time in them. So for example, if you talk about sales in a month, so it's like a period of months that you have the data in, measured. And on the other hand, when you talk about the stock variables, we just want them in a certain point in time. So for example, the closing price of Apple at yesterday, it's a stock variable. So it's like it's set. And then we have qualitative variables. These variables are not necessarily numbers, but could be numbers. But if they are stored in a number, they are for sure discrete variables. They are not continuous numbers. And so we could, so the main, I hope you guys don't open your microphones. Okay, thank you. It's very weird because I hear myself sometimes. Yeah, so so one important types of qualitative variables are categorical variables. So for example, if you have a variable called headquarter of a company here, it could be a US-based company or EU-based company or rest of the world. You can name them with some numbers. You can say, okay, I I assume 0 for this guys, 1 for this guy, and 2 for this guy. So this is like one way to deal with this stuff, to convert them to numbers. But this is something that you define yourself. So these are not inherently numbers. One famous qualitative type of variables are binary variables. So they are basically Booleans, 0, 1, true or false. And they have several names. They're called indicator variables, or in the context of econometrics, people call it dummy variables. And yeah, we will talk more about these things in the next lectures, but they're very important. So they're an important special case of qualitative variables. Okay. Next. Okay, types of observations. So we have 3 main types of observations. We have, so we call it data cross-sectional. If we observe the variables by the cross-sectional units. So what do I mean? So, so for example, if you have observation about some people, some companies, some countries, but you have just one observation per ID, okay? So then you will have a cross-sectional variable. So for example, you have the population of several countries. So country I has this amount of population. And then the way you address variables is by the index I. So you call xi type of observations. The other type of observations you could have is a time series. So basically you have a certain number in a time. So for example, GDP of Germany in 2010, in 2011, 2012, and so on. And you have kind of a mixed way of having cross-sectional time series. Then they are called panel data or longitudinal variable observations. So they are indexed by IT. So it could be that, so you have for country I, you have several years. So for country I, for Germany, 2010 until 2016, for Greece, the same, and so on. So you have several I's and several T's at the same time. And they are called panel data. And there are many examples of them. So you can see here, but as I just mentioned. Any question on this? Okay, great.
You say this clear that you want a 2-dimensional or 3-dimensional array. I think the data cleaning problem is more that the data that we receive quite often comes in text files. The data cleaning basically is assigning the data yourself.
Yeah. So before we talk about the data cleaning, it's important to identify which type of data we have. And that's why we go to the tidy data set. So as soon as I get the definition of tidy data set, you can see what does the tidiness applies in each of these contexts. So yeah, that's exactly where we are now. So we call a data set tidy if it has 3 main properties. The first is, so in a data table, so just remember data table is just a single, for example, Excel sheet. And a data set is like an aggregation of several data tables, okay? So we talk about the data table. If in a data table, each observation forms a row. So for example, if you have a cross-sectional data, you have country I, and everything you see about country I is there. So you don't have 2 rows for country I in a cross-sectional setting. The second important property is that in a data table, each variable forms a column. So you shouldn't have multiple columns about one variable, okay? And third, each kind of observation forms a data table. I will show it in an example later. And fourth, if you have a relational data set, a relational data set, it means you have several data tables that they are related to each other. You should be clear about the links between these tables. Okay. So how you can,
Professor?
Yeah.
Sorry.
I don't know if I can, just a moment.
Can you hear me?
Yes, I can hear you, but the others don't hear you. That's the thing.
Just repeat the question.
Okay. Okay, just tell
Yes.
me.
I just have one question concerning the infrastructure. When other people like Professor Lagenberg speak in the classroom, I cannot hear it clearly.
I see. So the problem is that when others talk, like you ask a question, students didn't get it. But I don't know if this solution works. So if you talk now, I guess I think I can pass it to the students when they want to have a question. No, but the students don't get it. Ah, okay. Also from the students. Ah, okay. Oh, okay. Would be tough.
That could be a solution because I can hear you like 90% clear, but other people
Okay.
cannot hear.
I see. Yeah, okay. Yeah, we should think about this. Yeah, it's a bit weird because like I'm just talking to the guy and you don't see what I'm talking about. And it's like I'm talking to myself sometimes. Don't worry. Yeah, we will think of a solution that could improve the situation here. Okay, so let me talk about the third point here. Each kind of observation forms a data table. So for example, you have a data set on customer purchases of various products, okay? An ideal data set should contain some data tables. So the first data table should be purely on customers. So each customer has a unique customer ID and it represents one row, okay? So we have the information about the age, income, and so on. Then we have another data table about the products. So like product I, again, the cross-sectional data, product I has this type, this brand, this price, quality, and so on. And then we have a data table on purchase events. So we have a purchase event like purchase ID I, and that with this ID we can map any purchase to one customer and several products. Okay, so this is an example of a tidy data set on the purchases of various products that satisfies all these four properties. Okay, clear? Good. Yeah. And what is a work file? So usually you have a data analysis task to perform. So for example, your supervisor asks you, I need to know, for example, what's the effect of X on Y. So the first thing you should do is to make sure that your data set is tidy. So this is exactly what we just talked about. And second, you should create a work file that is able to create the final data set that you want to do your analysis on. So you should have a raw data of all the data that you have, and there should be a process that cleans this data and select those important observation or variables that you need to do the analysis. And this big file, this Python or whatever file that contains all these commands, they are called work file, and they are usually very good documented, could be repeated many times, and you need you can just easily share it with the other colleagues. And then later on, you can start with your analysis. Okay. Yeah. Okay. Now, like main part of this work file is the merging process, because you have usually several data tables that need to be combined in a way. Okay. And this process is called merging, but it has other names like linking, joining, or matching. So joining is usually used if you are talking about SQL, and the others are interchangeably used based on what you have. So for example, in startup, people say matching, and so on. So there are three main ways that different data tables could be merged. So the first one is a one-to-one merge. So basically, For each variable in first database, you get just one link to the second data. You could have a one-to-many. So, for example, this guy could be merged to several observations in the second database, or it could be many-to-many. So basically, each observation could be repeated inside the first data set and also in the second data set. Okay, so yeah, now I'm going to each of them one by one. An example of one-to-one merging is that we have now first a data on country and the land area, and we have another data set about the country and GDP per capita. And if we just merge these two data sets, we get this final data set that for each country, we have land area and GDP per capita. So this is our final file here. Okay, this is very straightforward. The second way is if we have a unique data set here, which is like individuals, individual IDs, 1, 2, 3 to 7, and then how many years of school, okay? And then they have a family ID. So these 4 people are belonging to the same family, and these guys are for the second family, and so on, okay? And we know that for each family, we have an indicator for how much they spend on their food. Okay. If we merge these two, then we get a third table that for each individual, we can get the food expense. But this is a kind of a duplicate that for like all these 4 people that are for the same family, we get the same food expense and the same food expense for the later on. Okay. Also clear? Okay. Now I want to talk about the many-to-many. But before that, I just want to mention, whenever you see this sign in my slides, it means that it can be very costly for you. It could cost you your losing of your job, or at least I know many people who are failed during their interviews just because of mistakenly using many-to-many merge. Why it is very important? It's because first of all, I never saw in my own case like a case that I needed many-to-many merge. So this is rarely needed. I also couldn't find any good example to show you. I just created one that I can show you later, but it's rarely needed. Okay, and it is computationally very expensive because if you have m observations here and n observation here, your final table could be m multiplied by n size. So for example, if you have 2 GB here and 8 GB there, you easily can create an 16 GB, which is usually more than your RAM. And yeah, there was like once in an interview, one of my friends explained me that the interviewee said, okay, we need to do this many-to-many kind of merge. And if people did such a thing, those data sets was on fire or something like that. So it was like such a huge computations usually for many-to-many. Okay. Just one more important thing. In the case of Pandas, you can always validate your merge to make sure that it wasn't a many-to-many merge. I will show you in the second part of the lecture today how you can do that. But now, after that, you realize that this is not needed. But what is it exactly? So assume that, for example, we have some students. So the same student here with several courses, so math and biology, and so on. And we saw some grades, okay? And now we have a table of converting the grades to how many points it could be there, okay? So if you get 10 points, you get an A, 9 B, but 8 also translates to B, and so on. So there is like also not a unique identifier here, also not a unique identifier here, okay? And when you merge these two, you can create the third table, which is for several observations of the same student. So now you have 4 observations for the one student, okay? And for the math, it could be 9, it could be 8. So I guess you can see why it is not needed. So basically, whatever kind of question you have in mind at the end, you shouldn't end up with these observations. And just for your information, this is not a tidy table anymore. Okay, because if we see, for example, a student as a unique identifier, we don't see one per student anymore. Okay. Good questions.
I think we need time to understand what's going on. So, many students, many courses.
Yeah, basically.
They all have grades with capital letters. Okay.
Exactly.
And now you want to translate this into points with this grade to point translation.
Exactly.
Okay. But basically, all you have to do is to replace grade by point.
Exactly. And that's why for math, it could be that we have like if it is a B, so B translates to 9 and 8. That's why the final table should show both to us. And that's why it will be a mess afterward. And usually, so I saw sometimes for example, a master thesis that I gave the student like 100 observation, and then the final data set that I see as like 300 observations. And it's obvious that there is a problem in the merging. Okay.
Sorry, Professor, maybe this example is not so clear.
Okay.
So why a single student, I mean, the student with ID 1 have 2 math courses, but the student with ID 2 has only 1 math courses?
Yeah, so the question is why student 1 has 1 math at the end, and student 1 has 2 maths, and student 2 has 1 math. The reason is, yeah, it's just a translation, because if you look at A is just translate to 10 points, okay? But B, which is the student 1 grade, is translating to 9 and 8 at the same time, okay? So you need to reformulate your question in a way that you don't end up into this situation, okay? So if you had several tables, one table only for math, one table only for biology, you never ended up in this situation, okay? That's why you need to have a tidy data set, which means you have one table per observation, okay?
Okay, thank you.
Yeah. Okay. Now, let's dig into more mergings. So no matter of 1-to-1, 1-to-m, or m-to-m types of merging, you usually end up in the case that like some of the observations could not be merged, okay? Because when you merge to data sets, so it's basically you are merging with a shared key, okay? So for example, in this case, you were merging based on the grade, okay? That was the shared key, okay? So here, for example, you can see that B, A, and F is translated here. B, A, and F is translating here, but the other things is not there. So you ended up in a case that finally some observations are deleted at the end, okay? And so there is a way to control this. You can, for example, say that how you want to do the merging, okay? So if you have, for example, a left merge, okay? So basically the final data set that you will see has all the observation of the left data table. And for the right data table, those observations that are not merged, they are deleted. And for those that you don't have any observation in the left, they will be replaced by not available or NaN or something like that, okay? You can do it in the right. You can say it another way around. You can say, okay, the right table is the important one for me. I don't mind if some variables are going to be NaN, but still I want to have all my observation in the right finally in the final data set. Okay, this is when you do the right merge. If you are interested only on the intersection, so only on the parts that left and right having some shared keys, you can see you can have the inner type of merging. And if you want to have like an outer bound, so basically all the observation there, also from left and right, you can get an outer merge. Okay, is it clear? So I hope you can tell me what was this type of merge here. I also don't know, I just asked you. Well, it was a left actually, but it is in this case also an inner, basically.
Yeah, I would also think that it was a left join, but
sorry. Yeah. Okay. Yeah, exactly. In this case, so the command that I used to create this this table was a left merge, but I can see it. Yeah, at the end you cannot say exactly how it was, but you can see it also as an inner, because like those parts in the second table is like just dropped, so that we don't have them anymore. They're deleted, so you could say it's an inner. So all these things merged, but those who just merged from here remain at the end. Okay, could be both. Okay, so we had also a comment from Zoom. Sorry that I interrupted.
Yeah, I just wanted to add that in this case, we didn't have a unique identifier, so there was no one-to-one match, which is why both of the entries with a B got added to the final merge table.
Exactly. So this is like a good comment. So the reason we ended up in this case is that for both tables, we don't have a unique identifier. So the identifier here was like not unique. There are 2 observations for this, 2 observations for here, and the same here. In this case, it's a bit difficult to realize. Okay, anyway, you will have some more practices, and like mainly in the course, you will do lots of mergings. Okay, so this is an important part. And so the concept is also the same, not only in Python, in Stata and SQL, that I know them good. You also have kind of the same kind of merging. So you have like the same left, right, outer, and inner kind of mergings always. Oh, good. We have here an example of left merge. So as you see here, from the left, the Tom and James, they don't have any observation in the right table, but they are still here present with not available observations. Okay. And is it clear? And this is like the Panda comment for that. We'll come to it, but you can just explicitly tell that I want to be merged on this identifier and I want to have a left merge. Okay, great. Okay, now.
So can you merge or merge order? How to program Python. So merge has 4 arguments here. Yeah, the third one is the identifier, and it must be a column name in our database. So the merge command takes all the tables that have a header.
Exactly.
And you find one header here ID to be the
yeah, but the Yeah.
Yeah, but you have a message. How? Yeah, it's left or you say right or
Exactly.
router. And basically you ask Python to merge two kinds of variables. Yeah, DF customer and DF origin.
Yeah.
Is that, but that's not a header.
What do you mean by header?
In the merge list, the name appears and the product and quantity. Yeah, where does it come from? Because after the merge,
Yeah, so the name is coming from the first table. So this product quantity and date, they're coming from the second table.
the order here, the merge order, it says DF customer.
What is DF?
Here it says DF customer.
DF customer is the name of the first. So there is a
Okay.
DF customer.
So this takes all the
Yeah.
data from this table.
Exactly. Yeah, exactly. So this is actually the definition of left merge, because we base our observation on the left database. So this is the important database for us. It doesn't matter for us if we don't see something in the right database here. Okay, but we want to have everything about Tom. Maybe we need to merge something else, but we need still Tom later. Yeah. I can't hear you, sorry. Yeah, but concatenate is another concept. So it's like a bit broader than just merging. So there we could, so in merging, the important thing is that we need to have kind of a shared ID. But when we just paste two tables next to each other, we don't need necessarily a shared key. Okay, that's the main difference. But yeah, otherwise you can define the concatenate also as type of a merging. It's outer merging, basically. Yeah. Any other questions?
That's great. As far as I understand, that's how we use both where statements and joins.
Could you repeat again? Sorry.
Pandas merging with the only option. Those fields are like the tables without merging.
But you can concatenate, no? Yeah. So, but
The extractation from the tables without creating.
yeah. There's two ways to do the merging. I'll show you. You can just create a third table, and you can just have the first data and just merge it, something to it. Yeah, there's both possible. Yeah.
Table, how do we consider about the ID of the table? Here you have put like number 0, 1, 2, 3, 4, and 5. But at the end, you should have unique data and very tiny table. So would Python itself create this ID?
Okay.
Or should be asked?
Okay, good question. So for the Zoom people, the question was, so how we manage this this index at the end, right? So you're talking about index. So in Pandas, you can explicitly tell them how to do that. But indexes are not the important thing here. So the only important thing is your identifier. So here the ID is the important one, and you can see the same ID appears here. Okay. But this index is like you can just reset it or you just recreate it or whatever you want to do with it. It's not the important part here. So this is just for the pandas to understand there's a new observation. So yeah, this is so for Panda, everything is a tidy table because they have it has its own unique index, whatever you do with this data. Okay, but for you, it's important to just realize that you have an ID and it should be unique at the end for your analysis. Okay. Again, this is not a tidy table because you have like two. It depends. Like if because you have a date here, it is a panel data maybe. It's okay to have several observations. But if it wasn't, if there was no date element here, and it was purely a cross-sectional data set, then we shouldn't have two Jenny here. Okay, that's important to notice. Yeah. More questions?
Professor?
There's a Zoom. Okay.
Could you?
Suppose we want to have,
Sorry.
if we want to make this a cross-sectional database, and therefore with only one row for journey, and there were two columns or as many columns as there were products. So probably purchase.
Yes, it's called pivoting. Yeah. So I will explain it in a moment. Yeah. Basically, you can do the same thing. So if this bothers you, exactly, so you can just reshape this table in a way that you have a product column. So yeah, you can differentiate there. Okay, but there was a Zoom question.
Professor, could you explain the first two arguments in the parentheses? Are they just some names for columns or rows, or they are some
Okay.
documented variables?
So the question is like, what is this comment here doing? We will come back to it, but just for your information. So this DF customer is the name of this data set here. So I don't know if you can see it, it's here. And the DF order 2 is the name of the second data set. Okay. So we just call please merge DF customer and DF order 2, two different names of two tables, and on their IDs, and do a left merge.
Okay, thank you.
Okay. Good. Now we can do more cleaning stuff. So the first thing we need to have an entity resolution. So you, as I said, you need always to think what kind of data you have, if it is a cross-sectional or if it is a panel data, and what is the observation level that you need to have. Okay, that need to be a unique row that you want to have in mind. Okay, so for example, in the case of data, cross-sectional data, you have a cross-sectional data on some countries, each row should be one country, okay? Or if you have a panel data of annual revenues of several companies, your observation level should be firm year, okay? So you shouldn't have like Apple 2010 and again Apple 2010, as for example, you have here, for example, okay? So just the process of making sure that you have one pure observation in a row, it's called entity resolution. And so there are two things that you need to consider. First, you should just check for the duplicates in the observation level. So you should, so duplicate could occur during the data collection or data processing. So it's just when you collected the data, it could happen systematically. So you need to consider that. But the most important thing is there is a comment in Panda. You can just say drop duplicates of firm year or just country or whatever. So it's important to have your observation level and then drop duplicates based on that. The only thing that you need to be careful about is sometimes when you have like multiple observation level, maybe in one of your variables, there is additional information. So for example, there is like for Apple 2020, in one observation, you didn't collect the states. And the second observation, you gathered the state as California, okay? So you need to just make sure that when you drop the duplicates, you won't miss any additional information. The second thing is important to avoid using names or string variables as identifiers. So this is very important because, for example, if you have some football teams data set, yeah, if you want to have name of Manchester United as an ID instead of a number, so you could end up with several names. So Man City, like man with dot city, Manchester City FC, like Manchester City itself. So it is, yeah, it could be complicated, and yeah, you could end up with several observations per unit. So, and it's not easily, then you cannot easily drop duplicates then. Okay, so just make sure that you don't have a string variable as your ID. And if you have so, you just need to make sure yeah, you don't have this kind of problems in your data. So for the financial data, it is also important because usually when you collect the data, they are on the ticker level, and the ticker variable is also a string. So this is especially important in the financial data. Yeah, but you need to just do the entity resolution to make sure, like, you need to list all the observations to just make sure that there is no deviation from the actual name. Okay, any question? Okay. Okay, then another important thing, missing values. So first of all, why missing values could be problematic. So first of all, they are difficult to identify usually. And sometimes, for example, when you are given a data set, you can see that there are some zeros, and you don't know if it is replaced by 0 or it was actually 0. Okay, this is one important thing. So that's why you need to always check for the extreme values in your data sets to make sure that, for example, if there are too many zeros, that could be a problem. And sometimes, so for example, you have to work with a column of strings, and some of those strings are like NAs, which is still a string, but it is basically a missing value. So this is, first of all, this difficulty to identify these missing values. The second thing is, so missing values means that you have less observations. And for example, if you have a regression to make at the end, if you don't have enough observations, your statistical inference has not enough power to explain things. Okay, so this is the second problem. And the most important problem is the sample selection bias. So what it means that your dropping values are not happening randomly. So for example, you have a survey at the end. So you have data on a survey, and some people didn't answer to specific questions. Okay, so you cannot assume that this is like a normal missing value. So you have a sample selection bias, and the bias happening in a certain kind of observations, and this will distort your analysis at the end. So when you want to talk about the data or talk about your inferences, you need to make sure that if there was some missing, it was happening randomly. So there is usually ways to deal with this sample selection bias, and this is called benchmarking. So basically, what you're doing, you can select some other columns and then check the summary statistics, so the mean, standard deviation, for those who have the missing values and for those who doesn't have the value. So this distribution should be similar. Okay, this is one way to just to spot if this is randomly missing or not. Okay. Okay, how to handle missing values. So most importantly, you should make sure that there is no other alternative. Okay, it's very obvious. And then, yeah, you make sure that there is no other data set available that provides you with this information. Then, okay, you can ignore them. Okay, so this is life is not perfect. You can, but you need to just check for sample selection bias if you want to ignore these missings. You should make sure that this is happening randomly. It's not systematically some observations that you miss. Okay. And you can also do something more. You can, for example, say, okay, if most of the missings that I have are, for example, you have a data set on several companies, And smaller companies, maybe they are not great in reporting their data. So you have most of the missings from smaller companies. Okay, so you can just say, okay, I don't want to do in my analysis anything of the small companies. I just do it for the medium and large companies. And then in a robustness check, you can include them. But yeah, this is, you need to do a separate kind of analysis at the end. Okay, but the main thing is you cannot do anything with them. Okay, so just accept it. There is another approach that people in economics usually don't do. This is because basically you can impute the variables in a way. You can just replace the missing values with the average of what you can guess or whatever. There are many other ways. So for example, for time series, there are lots of imputation techniques that you can fill some missing gaps. If you have, for example, quarterly data, you can just say, okay, for Q2, I just replace it with this number. But you should always remember that this doesn't add any information. So you just basically, fill some observations with no information. Okay, and especially if you are doing some academic stuff, yeah, this is very dangerous. So you never do this. Okay, any question? Great. Okay, so I just took the picture of this review box 2.4. This has a nice to-do list for when you face the data. Okay, so first of all, you need to remember that when you are cleaning a data set, this code that you are writing should be repeated many times, because at the end of your analysis, you just realize that you did something wrong. You need to do the whole process again. Okay, so that's why you need to have the codes that could be improved later. Okay. Then you got your data set. Yeah, you need to understand the types of observation and what actual entities make an observation. So basically, you understand if it is a cross-sectional time series or a panel data set. And you need to store the data in tidy tables. So you create several tidy tables. And then you can start resolving the entities problem. So you can just find if there's a duplicate or if there is an ambiguous entity, or like some rows that don't have any entities and so on. You just drop them. And 6, get each variable in appropriate format. So for example, if there are some columns with some weird names, you just rename them. You add some labels that if you find them necessary. And 7, make sure values are in a meaningful range. So you should just check if, for example, there is not many specific numbers there that could be replaced with those numbers, or just make sure that you don't have out of range variables. Number 8, you should identify the missing values and store them in an appropriate format. Number 9, so this is usually at the end. If you just look at your final tables, could be the case that you missed something, and you should always think about the data, how have you managed them, if there was a mistake in merging the data, and so on. Okay, and you need to have a description of all the variables, because not everyone can know everything about your data, and you usually need to show so for example, if you have an academic paper, you need to at the end to submit all your variable description to the journal. Okay, also the same thing happens in your jobs. Maybe you need to show it for your next colleagues. You maybe leave the company one day and the next guy should be able to see what you did with the data. And that's why it's very important at the end to have a very good documentation. So basically the documentation is one of the presentation subjects that one of you guys should do it. But I just want to mention important things here, okay? So you usually when you have a folder of your tables, your data, and your codes and everything, you should just have a README file, and usually it's all capital README. Okay, and you create this because no one can read your mind. Okay, so you need to have the documentation somehow. It is usually stored in a TXT file or a markdown file. Also, how to create a markdown is one of your presentations topics. And then you usually put it in the root folder. Okay, so if this is like the structure of the folder, you have always a README MD file, and then you have your folders, your codes, and so on. Okay. And if you want to have a nice table, like a tree view of this stuff, you can in your Markdown or in your Jupyter notebook, you just start with 3 columns bash, and then you just close them. So if you do this and enter, it will be a very beautiful table. And then yeah, so this README file should have some minimum contents. Usually you should have a title for the data set, okay? And then you should have your own contact data, how people can reach you if they have questions. Where is the data coming from? It was a survey, it was collected from some websites, some data sets, and so on. You should have the clear folder structures as here, and then you should have a description of what each file has, okay? So for example, file A, XLS in this folder means this has this kind of observation there, and so on. And this code does this, and so on. It's also important to mention if there is some license or restriction on the type of the data, or can people share the data or not. This is also important. There's always a description of the methods that use for the data processing, how you just, so you usually maybe don't need to put it in the README file. You could also do it in the as a comment in your codes. Then also important to have a variable list, full names and definitions, okay? And so if you have like a specific symbols in your codes, there's specific weird names, you need to mention them in your documentations. There are some samples for that. So Cornell University have a very good README creator that you can just replace the things for your own data sets. Yeah, this is basically it from my side. So I think we have still half an hour to start with Pandas. Okay, I guess it's better for me to sit here.
Should we open the same Panda on the laptop, or should we just watch?
Up to you. If you want to just play around with the commands that I'm just introducing, maybe it's not a bad idea. Good. So, yeah, if you did some data science stuff before, you for sure know Pandas, because this is the most popular library for tabular data. And yeah, the good thing about Panda is that if you can work with Pandas, you can just implement it in your Excel. So people do VBAs, but you don't need VBAs anymore. You can just use Panda as your backend and just, yeah, do whatever you want with Excel with Panda commands. So Yeah, I'm telling you this because if you go to the financial industry, people love Excel and they don't want to have things on that. And people, yeah, I think VBA is not a great language, so you can use Python. Good. One good thing about Pandas is that so you can work interchangeably with spreadsheets and SQL databases. So this is very handy, and it has a very nice documentation. It has also a cheat sheet that I just want to show you. So basically everything that I'm talking today, you can find them here, and they're all hyperlinked. So you can just go to the main definitions if you want. So it's very nicely documented here as well. Okay. Good. Okay, so have you imported? You can say import pandas. It's also abbreviated to PD, so you can import pandas as PD and then start with PD something. Okay, so have you create a Panda data frame? Okay, so the important thing is that you have two main objects in Panda. So if it is a series, so it has a one-dimensional data. So you have like some, for example, a time series, you have an index of time and some observation, which is, for example, GDP. Okay, so it is a single dimension thing. We call it series. If it has two or more dimensions, more columns, it's called the data frame. Okay, so just imagine a normal Excel sheet, and it's you can just imagine it as a Panda data frame. Okay.
Series is clear. That's a series over time, and the data frame is cross-sectional.
No, it's like any Excel file with more than one column. It's called a data frame. So, okay.
And also, a series doesn't need to be a time series necessarily.
Exactly, and times, yeah, series are not necessarily time series. So time series are a special kind of series that their index is a time variable. Okay. Have to create a series. You can just say, okay, I have some observations here, and you can have a list of observations, or it could be a NumPy array, and then you can say Panda data frame. You can have the columns, the name of columns, and the observations. Okay, so you can just see it. So if you don't specify a name for the column, it will be starting from 0, 1, and so on. Okay. This is basically an example of a series. You can have, yeah. You don't see it? How about now? Yeah, if you have multiple dimensions, you can already be a data frame. Okay. So data frames could be identified with indices and columns. Okay. So you can, so the indices are by default some numbers. You can just rename them to dates or to some string numbers. So instead of 0, 1, 2, 3, you can just rename them A, B, C, D. You can also rename the columns from whatever to whatever you want. So here, I just want to rename the columns as AA and BB. Okay. And it's
Excuse me.
yeah, yeah. So
So the default is to set
So later the
the
observations will become.
yeah, just continue, please. Continue, yeah.
Okay, so is that correct? The default is to set the observations A as a column vector.
Yeah, so
Okay.
basically when you define when you initiate a data frame, you should like name your columns. So it's like an Excel. You need to have column names for your Excel file, for Excel sheets as well. So this is basically the same here. So we have a question.
here the word list,
So we created from lists. Yeah.
and also doing class, right?
What do you mean?
The classes that you mentioned in previous course.
Okay. Well, a data frame is a class. So so data frame. So when with data frame, you create an object actually. Yeah, this is correct. So the main objects that you work in the pandas are series or data frames. So that's like, yeah, this is how it works. Yeah. So if you have a question.
Later on, there will be CSV files, text files.
Exactly. You can just import CSV files and so on, and then it will be automatically a new data frame. Yeah, I'll just show you in a moment. So exactly here. So you can import, read Excel file, CSV file, many more formats. So for example, so then you see read. So you can, it can, if you just copy paste something in your clipboard, you can just paste it from your clipboard. You can read some CSV file, Excel files, some feeder files. Feeder files are great if you work from R and you want to just come back to, so you want to store something from R or other language to Python. This is the format you want. There are many other formats. HDF you need for the TensorFlows when you did some machine learning things and you stored them. From HTML, you can create some tables again, and many more tables. So also from Stata, if you have a Stata file, and so on. Okay, but here I just created in my own Dropbox actually. I created some text stocks, stock prices, and we just want to work with this today. So that's why it's an XLS file. So it's an Excel file. So I read Excel, this XLS file, and I need the sheet name main. I can just press here this, but you need to remember for Excel, Pandas use another libraries to read this. Okay, so you need to install a backend library. There are many alternatives, but the one that I'm usually use is OpenPyXL. So you need to install it with PIP if you want, and then you can read Excel files. Okay, that's why it first collects the OpenPyXL, and then you can read Excel. Now it is installed, and then it will read the Python file. Okay, so this is the data frame that was in an Excel file already. Okay, so this is, you can see already there are 3,000 rows, and there are 7 columns. So there is like some identifier. So I got this data from CRISP. So CRISP is the most important database for stock prices. It was gathered by Ujin Pharma in Chicago. And yeah, it has the historical prices for all the stocks. Okay. So you can see Permno as a main identifier. And then you have the date for each date from 2018, I guess, until 2020. I gathered this data. So there's a ticker symbol for Google until Netflix that you can see, and their company name, BDASK average, the return, and what was the daily return on S&P 500 index. Okay, this is the data I just imported. Now, assume you want to work with certain columns or certain rows. How you can do that? I want first to see what kind of tickers we have here in the database. Okay, so we can just call so the name of database, which is a DF. So I just created the DF here. So the data frame here, and I want the ticker symbol, the column ticker symbol, and then I just want to see what kind of ticker symbols we have here. And you can see we have Amazon, Apple, Netflix, and Google in all this data set. And if I want to have only the Apple returns, I can say that, okay, I need those part of data frame that the data frame ticker symbol is equal to Apple. Okay. And if I say that, then I just got these things here. Okay. So it's all the apples. And you can see there's just 756 rows. Okay. Yes. Yeah. Set is so when you have a list, you can have a list of something. So you know the list in Python, okay? So the list is this basically with many duplicates. If you want to remove the duplicates of a list, you can just make the set. That's why I don't want. I just want to see the unique names here. Yeah, good question. Anything else? Okay. Good. Okay. One important thing is that for Panda, so Panda knows the data set based on their index, okay? And as the main index was already from the 756 observation for Apple, it remained here, okay? If you want to rename them from 0 again, you can just reset the index, okay? And the drop true means that you drop the previous index that was there and replace it with the reset one. So now you can see it starts from 0. If you don't have drop equal to true, then you have the previous index, and in addition to that, the new index. Okay, so if you want to select a row, so you can just select the first row. You can say, okay, I want the I location of 0, so which means this row. And you can get everything here. So what was the parent node? What was the name of the name dates, the ticker symbol, and so on. Okay. You can at the same time say I need a range of rows. So from the 0 until the last 2. So I don't want the last 2, but I get from the 0. No, I'm sorry. Oh, sorry. This is actually telling you, yeah, I need the iLoc, so I need the first row as I had here, but I just need the last 2 columns of that. So this is a row and the columns. So it will basically give you the return and return on S&P 500 if I have this. Okay. You can also select multiple columns. If you want to do that, you need to have 2 brackets here. So you need to say, okay, the first bracket, the list of columns that you're interested in, and the second, so I need to have these columns, and you can see it there here.
Sorry, can you just answer the question?
Okay, that's a great question. I didn't know that. So honestly, I don't remember. If you don't do the reset index, I think this is referring to the number that you see, but we can try. No, exactly. Yeah, let's have this without resetting and say I want the iLook. Still the same, yeah. Exactly, yeah. It counts them, yeah. That's why you need to reset index usually to just make sure that you don't get into the troubles. Yeah. Okay.
Like a dictionary then, but here it's not the key, here is just like 0 with like first row.
The first row, yeah. Exactly. Yeah. This 0 doesn't. But this is weird a bit for me because I thought the other way around. But yeah. But maybe that was the reason I put it here to just tell you that's important to reset index always. Without I, you mean? Yeah. Exactly. Lock is a different thing.
Just to answer the question, what would happen? Yes.
So what lock does,
Yeah, I thought this was the question.
okay, yeah. Yeah. But you know, the weird thing is that these guys in the Zoom don't hear you. And okay, but we can have the conversation here if you want. Yeah. Okay, sorry. Okay, let me continue because we don't have time enough. So you could have multiple conditions applying to your data frame. You can say, okay, I need the data frame. So what I need actually, I need the data frame that that the date names are bigger than this date, 1st of 2020, and this to date time is to just tell Panda that we want to have a date comparison. Okay, so if you want to create a date variable, you need to say, okay, this is the string variable and this is the format of that. And this is just converted to a date, and then compare your date variables with that. Okay, and then and so there are some multiple conditions. So we need the dates that are bigger than 1st of January 2020. The price or bid ask squared is more than 100, and we want the ticker symbols are in this list that I'm defining. So I just want the Apple now, but you could say we want Apple and Google. I don't know if it was Google or Google. And then the perm no shouldn't be non-available. Okay. There are basically different ways to define the conditions. So I try to gather all of them that you maybe frequently needed into one big query. And then you can just say whatever is this, just reset the index on that. And now we can see the result of this query. Here, we didn't drop the index, and that's why we have an index already here. This was the previous index, and it was created a new index here from 0. Yeah.
Why are we accessing the terminal via property? Yes, I have brackets.
I think
in the row above, we use brackets and then pick a symbol. Why aren't we using that?
We can do that with the perm no. If you have the number of perm no, that's the thing. So I just don't know. I don't remember the perm nodes for Google, but I know the symbol, the ticker symbol. It's easier for me to remember. Yeah, but basically you can do the same. So you can say if it is in these two numbers. So you just define the list, and if it is inside this list, it will go through. Okay. Do we have questions? Okay.
So the selected rows are the rows that satisfy all these conditions, right?
Sorry, could you repeat again?
Yeah. So the sample we created is the data which satisfies all these requirements, right?
Exactly, because we
Okay.
have, yeah, it requires all these 4 conditions because we have and here. You could have or, sorry, here. You could have or. So then you can compare and or and so on. So there are just some logics. Yeah, I don't want to do it now, but yeah, basically you can have and or. The important thing is you need to separate your conditions into the parentheses. So this condition is in one parenthesis, the other condition in another parentheses, and then you can just make sure that you have some and some or, and they are like separated enough. So you have like 2 ands in one parenthesis, and then have a big or, this or that. Okay.
Okay, thank you.
Yeah. Okay. So one good thing about Panda is that there's a nice command called describe. So if you have a Serie, you can describe it. So you have, for example, we have the bdesk average, and when you describe it, you can say we have this amount of observations with this average, with this standard deviation, and this percentiles numbers. So the mean and max as well. Okay. You can have the mean of that. You can have the standard deviation, and at the same time, you can also use the NumPy methods. So, for example, you can have NP mean of this the data frame. It will be the same. Okay. You can also apply some functions to specific columns or rows if you want. So, for example, I want to convert the return to %. So the returns that we have here. So let me first show you. So we have these returns variables here, and we want to convert it to %. So I just want to, for any variables, I want to apply this function. So this function basically get a number and multiply it by 100. Okay, so you can say I want this column to be mapped with this function. So basically each row will go through this function, and it will create a new column for me, which is a % returns. I can do that, and then you can see at the end it will create this column for you, which is just a multiplier of 100 to the return. Okay. This map, so when you have map, it means that you have a function that you want to apply this function to this column. There is map, and there's an alternative to that, apply. So basically have the same. I haven't done that. So if it is possible, I don't know. But this is the standard way. You can create the function instead of just defining a function. You can use lambda. So with lambda, you can just create one-line functions. So you can say for input x, lambda x, or if you have 2 x and y, you can say lambda x and y, and then whatever you do on that. So you have a function with 1 x, and then the return should be x 100. So you can just map this or apply it. Okay, would be the same. Okay.
What is the lambda thing doing?
Lambda is like if you don't want to have a defined function elsewhere, so you can just lambda a function, and this would be like just a for small functions, it makes sense to make it lambda. Yeah, you don't need to define a function.
One question.
Yeah, question.
Yeah, so you set the returns multiply with 100 twice. So why the second time still 179?
Okay, that's a good question. So he said that we did several times multiplication by 100. Why it is still just 1 times by 100? The reason that is that I got the return variable, which is unchanged here whenever I do that, and I create this person returns. So every time I run this line, I just use the same variable. So I don't use the already multiplied one. That's the reason.
I see. Thanks.
Yeah. So another important thing is group by operations. So you can group the observations based on a family. So for example, the family we see here, so we have a panel data here for tickers and dates, okay? So we can group by the tickers and do some calculation on them. So we can say, okay, I want only the, want to see like stock by stock and get the description on the returns, okay? So basically, I group by them and describe them. So for each, so now when you group by something, then the index is changed to your group by index, okay?
What happened if they wouldn't describe it? It just brings the groups.
It won't be anything. It will be a class. So it's an object now, and then you need to apply some methods. So group by is just a method. Yeah, so you can add several methods. So this is the list of them. You can get the mean, sum, count. You can have describe. You can get the first element, last element, or you can get the nth element. You can get the minimum of that or maximum of that. So you can just say what's the maximum return of any of these stickers. So you can see that this is the maximum of that.
So it basically groups by taking the sticker symbol, it groups unique values and then applies them.
Exactly. Yeah.
How do you get this list online? Does the stop function?
It is already in this link here. So it's in my Dropbox, and when I shared it with this link, so that's why you can just read Excel and you could.
Yeah, no. If I want to know what kind of functions for group by
Okay.
and some, you have posted them here as a picture.
Yeah.
But if I don't have this picture and I want to see it.
Okay, that's a good question. You can always Google Pandas group by functions. And there is the group by, and then you can say the functions that you can have. Yeah. So there's a list of everything here. Okay. Really don't know what I did here. I think with aggregate, you can impose your own functions. So for example, if there is a function you define somewhere that you want to apply to this group, or like predefined NumPy functions, you can aggregate and then pass these functions, and it will do that. So you're not bound to use only these functions that are here. You can have your own functions, which is basically, yeah. So you can say that, yeah, I need the mean and max and standard deviation based on this group, but not calculated by Pandas. I want to calculate it by own functions somewhere else. Okay.
The first group by visual values, and then from there we take only returns, and from that we apply.
No, this is like, yeah, this is basically the groups. This is the variable that has. So this is the object grouped already, okay? And I want to apply some functions to a specific column of that. Okay, so I need the column returns, and then I want to apply these functions.
So it's the same as last time, only more things.
More things apply, but you can have your own functions and apply them here. Yeah. Yeah, sometimes you need some weird things. So for example, you want to have on ends observation, do this specific thing, and then do that other thing. So you need to have like some weird specific function for yourself, and you want to pass it to the group. And this does this for you. Okay, let's talk about reshaping. So pivoting is something that was mentioned during the lecture. So basically here, the data we have is we have an index of time. So for each time, we basically have several tickers. Okay, if you want to have a unique time rows, so if you want to reshape the table to have just rows, we can use pivoting. Okay, so in our case, we have like this date. So for same date, we have several components. Okay, but if you want to have just one date and Google return here, Apple return there, so we just convert to several columns, we can use the pivoting. So the important thing is that you need to say what is the index you want to have, which is the date. So I want to index on date, and which columns need to be created. So the created columns would be the base would be based on the ticker symbols, and the value that I'm interested in is the return. Okay, so this is the return of Google, and it will be created as a Google return here. Okay, so just want to do that here again. So first of all, I want to sort them to show you. So I want to sort based on the date. So you can say for this date, I have four values here. So we have Google, Apple, Netflix, and Amazon with several returns. Okay, and I just want to pivot them now. If I pivot them, I will get this. So I want to pivot on the dates. So we have like unique dates now, and we have the columns that the values that are important for us are the b-data spread average and the returns. So we have for each four. So we have basically first four referring to the b-data average, and the second four refers to the returns of Apple, Amazon, Google, and Netflix for each date. Okay. Great. And then important to note that now the column names are not the same as before anymore. Okay. So if you want to see what columns you have they are called multi-index columns now. So you need to say I need these columns. So I need price, average, and Apple as a new column. Okay. So for example, you want to say I need returns for Apple column. This is now a column. So you cannot say just Apple anymore or returns anymore. Okay. Yeah, basically you just multi-index them, the columns. Cool. So now let's talk about the concat. So this is also mentioned during the lecture. I'm sorry we are out of time, but I'm just going to finish it hopefully soon. Yeah, we can do the merging next time, but just the concat. So when you have two different data frames, you can just paste them together and create a bigger one. You can do it by default. This will be just adding new rows. So they're collected as new rows, but you can say that, no, I need, so there are different columns, so I need them to be merged in new columns. Okay. Yeah, so basically you can say if you have Google and Apple, then you want to have Google and Apple just, yeah, I want to show you, you have in the beginning, you have just the Apple returns, and then you have the Google returns. So you have just contract them into a bigger data frame. Okay, so I don't know if so we cannot for sure manage the merging, but yeah, but this is already good. I don't have any homework for you today, but if you're interested, you can still play around with the case studies that is provided in the book. So there are some small practices in this notebook that I just gathered based on the problem C1 to C4 of the book. The book pages are in the OLED. So if you go to OLED, to the course material, and then the course material, oh, sorry.
Data sets we use, you made them private. So if we share like this file, it's a box of data set. Yeah.
So you don't have the data set there?
Well, I tried this yesterday and I had some for myself. Data set because yours is private.
Just a moment. I can check.
This is why we can't run the same thing.
So there are people who tried already. So let's see.
There is an option like public.
I see. Okay, I'll take care of that. Thanks for mentioning.
That's how we work tremendously. Otherwise, we can't play around.
Okay, good. Yeah, I will. So you will have some practices on the pandas so far, but we can continue with the merging and so on for the next session. Okay, wait. The guys in the Zoom, I'm sorry, I need to say goodbye to you, but people here, yeah, if you have questions, I'm still here. So goodbye, guys in the Zoom.
Thank you. Bye.
Thank you. Bye.
Thanks.
Thank you. Bye.
Bye.